Okay, target 2 is about determining and applying the sum of interior and exterior angles of convex polygons. So let's look at some convex polygons. I just chose regular polygons to keep it simple. A three-sided figure, obviously, is a triangle. We know that all the angles in a triangle add up to 180 degrees. So a single triangle has 180 degrees inside of it. We've done that before. If I take a quadrilateral, I can split a quadrilateral, any quadrilateral, up into exactly two triangles. Well, each triangle is going to have 180 degrees in its angles. So this part of the angle, this top part of the angle, and then this corner angle, that's going to be 180 degrees. And then this rest of these angles is also going to be 180 degrees. So because I have two triangles formed, I'm going to have two 180 degrees. So 180 plus 180 is 360 degrees total. So a quadrilateral has 360 degrees. We also know that each angle in a square is 90. So 90 plus 90 plus 90 plus 90. 90 times 4 is 360 degrees. So a single triangle is 180 degrees. A quadrilateral can be split up into two triangles, which gives you two 180 degrees, or 360. A pentagon, my five-sided figure, if I pick any one of these vertices and I connect all the other vertices from that one, it forms three triangles. So again, if I add up all the angle measures of all three triangles, all of those, plus this one, plus this one, plus this one, plus the top, I have 180 degrees inside each of my triangles. So I have 180 degrees for three triangles. So 3 times 180 is equal to 540 degrees. Same strategy if I go on to 6 sides. I start with a corner and I connect all the other vertices and see how many triangles I can form. So this time I formed 4 triangles. Each triangle is 180 degrees. So 4 times 180 degrees is 720 degrees inside a hexagon. And then for 7, my heptagon or septagon, if I do the same thing, I connect all the vertices from one main spot. This time I have 1, 2, 3, 4, 5 triangles. Each triangle is 180 degrees, so 5 times 180. It's going to be 720 plus 180, which is, I believe, 900. Okay, so you can remember to take your shape and divide it into triangles. And we could keep going with 8 sides, 9 sides, 10 sides. You don't have to remember all of the different measures like 540 or 720 degrees, but you need to come up with how many triangles there are. Well, the question then becomes, what if instead of something with 7 sides, you have something with 24 sides? How many degrees are inside a 24gon? Well, if you draw out a 24-sided figure, that might take some time. Then you have to draw all the triangles, and that might take some time. So we want to look for a pattern. So when we had 3 sides, we had 1 triangle. 4 sides created 2 triangles. 5 sides created 3 triangles. 6 sides created 4 triangles. 7 sides created 5 triangles. My pattern is that there are always 2 fewer triangles than there are sides. So if I take the number of sides minus 2, that'll equal the number of triangles. So number of sides, 7 minus 2 is 5. That gives you 5 triangles. So if I had a 24gon, that means there's 24 sides. Minus 2 is equal to 22 triangles. And I could say 22 times 180 degrees for each triangle 22 times 180 is 3,960 degrees. So the process is number of sides minus 2 gives you a number of triangles. It's a number of triangles times 180. There's a formula for that that is useful to have. 180, again, the 180 comes from the degrees in one triangle. The n minus 2 stands for the number of sides. Minus 2, which gives you the number of triangles. And that's from our pattern. So here's an example. Find x. The polygon is regular. That means that all my sides are the same. So if I have 5 sides, that means I'm going to have 3 triangles, because 5 minus 2 is equal to 3. Since every triangle is 180 degrees, 3 times 180 degrees is 540 degrees. So all together, all of these angles add up to 540 degrees. If I want one of them, I need to take 540 and divide by 5. 540 divided by 5 is 108 degrees. So x equals 108 degrees. Another example, you're given a whole bunch of angles and you're trying to find the missing one. So first I need to count up my sides. 1, 2, 3, 4, 5, 6. So 6 sides means that you're going to have 4 triangles. 4 times 180 is equal to 720 degrees. So I have 720 degrees total. I don't want to add up all these that I know. So 100 plus 95 plus 120 plus 90 plus 100, that all adds up to 505 degrees. So 505 degrees plus x is going to equal my total of 720. So if I solve that, 720 minus 505, x is 215 degrees. Which doesn't look like it is in the diagram, so my diagram is not drawn to scale very well. But that's how you would do that problem. So that's the first part of target 2.